properties of a charge. Properties of charge. Okay, we are having the mainly 4 properties. So first one is additivity. Second one is conservation of charge. Next one is quantization. Next property is okay, additivity, conservation of charge, and the quantization. Okay, so here additivity means we are in the mathematics already we are having so many additions, numerical additions, that is arithmetical addition, algebraic addition, vector addition. Okay, so in the arithmetical addition we are having arithmetic addition means what? Here we are having the 4, okay, and the 3, it gives the 7. Okay, so algebraic ante enti? Algebraic addition ante 4 and the minus 3, so that is equals to 1. Ade vector addition aithe, vector addition is equals under root 4 square plus 3 square. Okay, so that gives the 5. Okay, so like this. Okay, that means here okay, arithmetic addition means 4, ఇది మైనస్ మోడ్లో ఉంది కాబట్టి పాజిటివ్ అవుతుంది. ఓకే, సో దిట్ ఈస్ 4 and the 3 gives 7 and like this. Okay, we are having so many addition process in the mathematics, but the charge can be added algebraic addition. Okay, so here charge follows algebraic addition. Additionless. Let us consider if there is a 12. Okay, so then there is minus 10. Okay, so that means here we are getting the 2. Okay, so the charge follows the algebraic addition, not the arithmetic addition. Arithmetic addition means 12 plus 10 22. Okay, so here charge can follows the addition last, that is algebraic addition. The charge means it is a scalar quantity. So that means here it is having only magnitude, not the direction. If the charge is the vector quantity, then we have to use the vector addition, that is under root 4 square plus 3 square. But it is a scalar quantity, so that means it has only magnitude. So that's why the charge can follows the algebraic addition. This is the one property of the charge. Okay, so this is the first property, and the next property is conservation of charge. Okay, conservation of charge. Already we know that from the 11th class already we are studying that conservation means what? Conservation of the momentum, conservation of the energy, conservation of anything. Okay, conservation means it neither be created nor destroyed. Okay, what we can neither be created, that is charge cannot be created nor be destroyed. Okay, so that means but it can transfer from one charge to the one body to the another body. We can transfer the charge from one body to the another, one material to the another material, but it can't be created or destroyed. Okay, so here we can transfer the charge from one body to the another body. We can transfer the charge, but which can transfer the charge? That is the electron only can transfer the charge from one body to the another body. Okay, so here proton, the particle which carries the charge is electron. Okay, the proton does not carry the charge because it is having the heavier mass, so that's why it can't move. Okay, now here conservation means already we know that the Einstein mass energy relation. In the Einstein mass energy relation, what? In Einstein mass energy relation, that is E is equals to mc square. E is equals to mc square means the mass will be converted into the energy will be converted into the mass. Okay, so that means here there is some transfer of energy from the mass to the energy to the mass, but not there is no any creation or any destroyed. Okay, so that means in the atomic bomb case, here we are having some special case, that is the atomic bomb. When there is some atomic explosion is there, when there is some atomic explosion is there, so then there is so in the atomic explosion, it gives the energy out. It gives the energy out means, so the millions of charges are destroyed. Millions of charges are destroyed. That is, millions of electrons are destroyed. Millions of electrons are destroyed means millions of charge also destroyed. So according to the conservation law, the charge can't be destroyed, but in the atomic bomb, when there is some explosion, then the energy can be created. So the energy is created by the destruction of the millions of electrons. The millions of electron means the electron carries the charge, so that means the charge also destroyed. Okay, but according to the conservation, it is not correct. So that's why scientists do some more experiments, and they found the new particle. So that particle is the positron. That particle is the positron. So positron means which is having the same mass, of electron, same mass of that of electron, and so positron is denoted by E plus, electron is denoted by E minus. Okay, so and it has the same charge. Okay, so they are found another particle, particle, that is the positron, which having the same mass as that of the electron, and same charge as that of the electron. So that means when there is some explosion is there, explosion means the electron, millions of electron will be converted into the energy. So if there is a electron and there exists some positron. Okay, so now here if there is a positive, 10 positive charges, 10 negative charges, so here we are getting the neutral condition, then by that neutral condition the energy is conserved there. Okay, so here this is known to be a annihilation. Okay, annihilation and the pair production also there, but these two are not important. Okay, so in the conservation of energy, mainly in the atomic bomb case, we are getting the maximum energy, maximum explosion. Why? Because there is so many millions of electrons are destroyed. So electrons destroyed means there exists some another particle is there, that is the positron, which is having the same mass of that of electron and the same charge of that electron. So that means those two are combined and give the maximum energy. This is about the conservation of energy. And the next, third one is quantization. క్వాంటిటీ అంటే ఇంత అని చెప్తాం కదా, అట్లా అన్నమాట. క్వాంటైజేషన్ అని అంటే, సో ద క్వాంటిటీ. ఓకే, సో దట్ మీన్స్ quantization is measurable, so measured one. Okay, so how much charge, that how much quantity, how much charge, that is given by the quantization. Okay, so here in the physics everything is quantized, in the physics everything is measured. Okay, so here already we know that the charge is carried by electron. Okay, so charge is carried by the electron. Okay, so one electron carries one charge, so that is one charge is carried by one electron. Okay, so that means n charges will be carried by the n electrons. Okay, so this n electrons gives the measurement, that is the quantization. Quantization means the integral multiple of electrons. Okay, so this is the integral multiple of charge on electron. Integral multiple of charge on electron gives the quantization. Integral multiple of charge on electron gives the quantization. Okay, so here n is the integer. N is the integer means, so n is the integer, so here E is the electron. Okay, So that means here quantization and measurable means it will not, it is the multiple of the integer means 1 2 3, n is equals to what, 1 2 3 4 like that. Okay, so n is equal 1 2 3 4 but not of 2 by 4 like that. Okay, so that means here we can measure the charges in the discrete manner. So like this, here 1 2 3 4 5 like this only. So in the discrete manner only we can measure the charges. Okay, so here we can't measure the charges in the continuous case. Okay, so it is not continuous, it is not continuous process of measuring the charge. Okay, so it is the discrete one. Okay, so here we can measure the charges in the discrete form, not the continuous form, because here we are using the integer that is n. N means 1 2 3 4 like that. We are not using the 0.1 0.2 0.3 like that. Okay, so this is about the quantization, conservation of charge and additivity. These are the main properties of the charge. Okay, so that is additivity and the conservation of charge and the quantization. Okay, so now we are enter into the new topic, so that is the Coulomb's law. Okay ma, new topic, that is Coulomb's law. Okay, so this law is given by the Coulomb scientist, that's why it named as a Coulomb's law. Okay, so now this gives the mainly the force which is exist in between the two charges. Okay, so here the charge is carried by the electron and we are having some properties, that is the additivity, conservation, and another one is quantization. Okay, and before the charge, so what is the induction and what is the conduction? We can create the conductor, that means we can charge a body, that is by the conduction and the induction. Induction means not touching. Okay, so conduction means we can touch the body. Okay, and also we are having some more the forces which is in between the nucleus and the electron. Okay, so now this is the topic about the Coulomb's law. This law mainly given by the Coulomb scientist, and he mainly focus on the forces between the two charges, two or any charge. Okay, so first he taken two charges, two particles. So this is a one particle which is having the charge q1, this is the another particle which is having the charge q2. Now already we know that the like charges means same charges. Like charges will repel each other, unlike charges will attract. Okay, so unlike means plus minus, like means plus minus. Okay na? Okay, so now these two charges I am taking. So if this is a positive and this charge may be negative, so the force, this positive charge will apply force on this charge and this charge will apply force on this charge. Okay, so as it is a first charge, so this first charge force applied on the second charge due to first charge. So this is the second charge. So this second charge will apply the force on first charge. Okay, so that is force on first charge due to second charge. This is the force on second charge due to first one. Okay, so now here this is the two charges which is having the positive and the negative charges. So the direction is like this. If here is the two charges, this is the q1 and this is the q2, this charge having the positive and this charge is positive, so this charge will repel this charge, so that's why this charge will go this side, that is away from the q2. As this is a positive charge, this also repels the first charge, so this will goes like this. If here is the charge q1, here is the charge q2, if these two are the negative charges, then this negative charge will repel this negative charge, so that's why the charge will be go away from the this one, and this also go away from the this one. This is the forces which are acted by the one charge due to the another charge. Now here the force between the two charges, that is depend on what factor that is given by the coulombs. Okay, so now here is the charge q1, here is the charge q2. Let us consider the force may be here this charge applies the force in this direction, this charge may applies the force in this direction. The distance between the two charges, let us consider the r. Okay, the Coulomb says that here the magnitude of force, here this is the direction of the force, no? First the direction of the force always along the the direction of the force always along the line joining two charges, అంతే కదా. ఇక్కడ చూడండి, ఈ ఫోర్స్ అనేది ఇప్పుడు ఇది లైన్ జాయినింగ్ ద ఈ టూ చార్జెస్ కదా. ఈ లైన్కి అయితే ఇటు సైడ్ ఉంది, అయితే అటు సైడ్ ఉంది, అవునా? అంతే, ఎలాంగ్ ద లైన్ ఉంది, పర్పెండిక్యులర్గానే అయితే లేదు కదా. సో హియర్ ద డైరెక్షన్ ఆఫ్ ద ఫోర్స్ ఆల్వేస్ along the line joining the two charges. And next second point is the force. Okay, so here direction is over, now we want the magnitude. Okay, so the magnitude of force, mainly depends on the magnitude of force depends on product of two charges and inversely proportional to square of the distance between them. Okay, so here direction, one part is over, the second part is magnitude. So the force is proportional to the product of the two charges, that is this one. And the force is inversely proportional, ante 1 by r, but square of the distance, so 1 by r square. Okay, so here from these two we can write the force is proportional to q1 q2 by r square. So this is the Coulomb's law. So now according to the Coulombs, so here according to the Coulombs, he given that the force is proportional to the q1 q2 by r square. Okay, so now here we have to get the what is proportional constant. Okay, he used some proportional constant, that is f is equals to k into q1 q2 by r square. This is a proportional constant. He given the some value of this k, so that k is equals to 9 into 10 power 9. Okay, so this is the proportional constant case, but in the free air. Okay, if medium is free air, that means here we are having the charge q1 and this is the q2, no? So if the medium between these two charges is air, then the k is equals to 9 into 10 power 9. Okay, now if the medium is water, if the medium is anything, another media is there, that means here q1 and the q2 is there. Now here I am sending the force, this is my force, so I am sending just 100 Newton force. So here some permittivity is there, some media is there, so it is opposing this 100 Newton force. It observes some 70 Newton force and it will apply the force only 30 Newton on the second charge. So that means due to the ability of the medium, here we are unable to apply the force that is 100 Newton on the q2. Okay, so that means here if there is a medium between them, if there is a medium, so then the permittivity of a medium, permittivity ante the ability of the medium to allow the force of the first one. Okay, so the permittivity means, okay, so here the permittivity of the medium will act some role when there is no air media. Okay, so if there is a permittivity, then he given the relation. So that relation is, this permittivity of the medium is denoted by the epsilon. Okay, so it is expressed in the number only, expressed in number. Okay, so here given the proportional constant k is equals to 1 by 4 pi epsilon. If it is a air media, this is the epsilon naught. If this is the other medium, that is the epsilon. Okay, so now here for the air media, epsilon naught is equals to air media, the epsilon naught given by 8.85 into 10 power minus 2. This is the permittivity in free space. Permittivity in free space. If permittivity in free space is 8.85 into 10 power minus 10, then k is equals to 9 into 10 power 9. Okay. Okay, if there is a media, then we have to write the k is equals to 1 by 4 pi epsilon. Okay, so the permittivity means the ability of the media to allow the force on the second force due to second charge due to first charge. This is the permittivity. Okay, that means here the Coulomb's law, the final Coulomb's law is equals to F is equals to k into q1 q2 by r square. So that is F is equals to 1 by 4 pi epsilon q1 by q1 q2 by r square. Okay, if epsilon is permittivity of free space, then 8.85 into 10 power minus 2. Okay, so this is about the Coulomb's law. Okay, Coulomb's law mainly explains the force exists in between the two charges. If the force always, the direction of the force is always along the line joining the two charges, and the magnitude of the force is proportional to the product of the charges and inversely proportional to the square of the distance. Okay, so to remove the proportional, there we are using some constant. That constant is equals to k. Okay, if that is a free space in the media between the two charges, then that is 8.85 into 10 power minus 2. If we are using some another media, so then the permittivity of that media will be depend on the media. So then we have to write the formula as F is equals to 1 by 4 pi epsilon naught q1 q2 by r square. This is about the Coulomb's law. Now we have to see the vector form of the Coulomb's law, and we have to see if there are so many number of the charges are there, then we have to see the field, electric field, and like that. Thank you.